Hi, in this video we're going to solve the rational equation 1 plus 3 over x plus 1 equals x over x minus 1. Now this is different, and the reason is, or different than what we've been doing, and the reason is now we're dealing with what's called an equation. Before we are just working with expressions. So if we look at this, this is an rational expression, this is a rational expression, and 1 is a rational expression. So each one are rational expressions. So let's make a little note of that here. These are all rational expressions. And we were always simplifying, and that's what you do. You simplify by adding, subtracting, multiplying, dividing, or reducing. That's what we do. Now, with an equation, though, an equation has an equal sign in the very beginning, and the directions become, every time, or most of the time, they become solve. Or you could say they become solve, or solve for, you might see solve for the variable. In this case, it's x, so solve for the variable. Now, before we do that, we have to notice one thing, is because these are rational expressions, we have to be concerned about the domain. So we need to check domain. And we did that in an earlier video, but as a quick review, what you do is you set each denominator to 0 to find out where the problem is undefined. So we need to look at x plus 1 equals 0 and x minus 1 equals 0. So here in the first equation, I subtract 1 from both sides, I have x equals negative 1. In the second equation, I add 1 to both sides. I have x equals positive 1. So, and we'll use this as in set builder notation. The domain is the set of all real numbers. X is any real number such that x cannot be negative 1 or 1. So what happens is, if this is the solution, then there is no solution. Or how about no solution exists? Okay, so we always need to be aware of that before we begin, so to see if our answers really make sense. Here we go. So there's a couple different ways to solve a rational expression, and I'm going to do it using the method of clearing fractions. So solve by clearing fractions. And you've probably done this before, maybe not in this to this extent, but for example, if I have a problem of like x over 3 plus 1 over 2 equals 1 over 6, then notice in this problem here, the lowest common denominator, the LCD, is 6. And we've actually found it for that particular case before. So to solve by clearing fractions, what we would do is we multiply every single term by 6. So we do this, we multiply every term or rational expression, I'm going to abbreviate rational expression, by the LCD. So let's try that and see what happens. So I'm going to rewrite this, and I'll write it in blue, the parts that we're putting into the equation. So I'd go 6 times x over 3 plus 6 times, I'll do it this way, 1/2 equals 1/6. So I'll leave the space, and now what we'll do is we'll put that 6 in. So times 6, so the 1/2 is multiplied by the 6, and the 1/6 is multiplied by the 6. So, but now watch what happens. So I'll do this in red, this is 6 over 1 if you want to think of it that way. But when you multiply 6, the 3, they have a common factor of 3, and the 6 gets reduced to a 2. Here, when you multiply 6 times 1/2, the 2's cancel, and we're left with 3. And here, a 6 times 1/6, well, everything cancels, and we'll be left with 1. So now, look at what happened. Now the problem is 2x plus 3 equals 1. And now the problem has no fractions and is much easier to solve. And so you can solve this by subtracting 3. Divide both sides by 2, x is -1. So we're going to use that technique on the problem that we were first given. So here we go. The problem is 1 plus 3 over x plus 1 equals x over x minus 1. Now notice that these are factored. The x plus 1 and the x minus 1, these are already in factored form. There's no more work to do. In other words, I'm going to need an x plus 1 and an x minus 1 in my lowest common denominator. So we can say that the LCD is x plus 1, x minus 1. All right, now I'm going to rewrite the problem, this time with some space. We'll write it 1 plus 3 over x plus 1 equals x over x minus 1. And then we'll do this in blue again. Now I have to multiply every single rational expression by the lowest common denominator. So I'll have an x plus 1, x minus 1, times, then I need to multiply the next one, so squish it in here. And the right side needs the same thing as well. Okay, now let's look at what we've just done. Notice in this, on the left-hand side, there's an x plus 1 here in the denominator, and there's an x plus 1 here in the numerator. Those would cancel. And we can do this again. Notice on the right-hand side, there's an x minus 1 in the denominator, an x minus 1 in the numerator, so those would cancel. So let's write what we have now. We have x plus 1, x minus 1, plus x minus 1 times a 3 equals an x times x plus 1. Now we need to do all of our distributing, combine like terms, and then see what remains. So here we go. So I'm going to go x times an x, that's going to be x squared. I'm going to move my screen up. Then I do that again, x times -1 for a minus 1x. Then I start from the 1, so I go 1 times x to get a plus 1x. And 1 times -1 for a minus 1. Plus 3 times x is 3x. 3 times -1 is minus 3. And this equals, and one more bit of distributing, we have x times x for x squared, and x times 1 for plus 1x. Now, let's clean up. So clean up, we're going to, by combining like terms, so we'll combine like terms. Combine like terms. So what do I have? I have On the right-hand side, here's a minus x and a plus x, so that's 0. And then, let's see, the other set of terms that I also have here a negative 1 and a negative 3. All right, so if I combine everything on the left, I have x squared plus 3x minus 4. And on the right side, there's no like terms. Okay, to solve this, well, notice that we have x squared terms. When we saw this earlier, what we did then is brought all of our x squareds to one side. So let's do that again. So I would take minus an x squared on the right, and let's move it over to the left. So I do the exact same thing on the left-hand side. Oh, look, those cancel. So now I have 3x minus 4 equals 1x. I'm going to bring my x's. This is a linear equation, solving this just like the one we did up above. So let's bring the x's to one side. So I have minus 4 equals minus 2x. You can see that x has to be 2. There. Now, and notice that 2 is in our domain. If we'd gotten a 1 or a negative 1, then there would be no solution. But let's just check our answer too. You should always check your answers. Check in the initial equation. So I'm going to just put x equals 2, and I'm going to put it in as we go. So the problem was originally 1 plus 3 over, it was x plus 1, but now x is 2, so it's going to be 2 plus 1. And we want to see if that's equal to the right-hand side, which was an x, which is now a 2, over x minus 1, or 2 minus 1. So on the left, I have 1 plus 3 over 3. And then that's a 2 over 2 minus 1 is 1. 3 plus 3, or 3 divided by 3 is 1. And 2 over 1 is 2, and that looks true to me. So we did it. And that is how you solve a rational equation by clearing fractions. Thanks for watching.